Okay, looking at number 13 now, they want us to find the dimensions. Notice not the total area here, but just the dimensions of the rectangle of maximum area that we can inscribe inside that circle of a radius of 4. So much like I just walked you guys through here on number 12, what I would probably do is set this thing up as a coordinate geometry problem with an x-axis right there and a y-axis right here, and we know that our radius in this problem is going to end up being 4. So once again, this is a floating dot problem. We are really interested in coming up with the coordinates x, y of that red point there, but though that point is floating somewhere along the circle, so we need to come up with the equation of the circle that red dot is floating around. So it's a circle centered at the origin, so its equation is going to be x squared plus y squared equals r squared, and since the radius is 4, we're going to put a 16 right there, and that is the equation of the red circle. Now, we know, I think, we're probably going to have to solve that equation for either x or y in a moment, but I'm not sure which one yet. I actually don't think it's going to matter at all. But let me move on to step 2, where we write an equation for what it is we're trying to optimize. We are trying to maximize the area of that rectangle. So we need a formula for area of the rectangle, which of course is just base times height. But how can we express that in terms of x and y? Well, the coordinates of this point right here, x, y, tell us the distances from the origin it took to get there. X units to the right, and then y units above. So the base of the rectangle, this whole bottom side, is going to be an x on the right, but also an x on the left, and 2x then is going to be the base of the entire rectangle. And I think you guys can see where this is going now. Y is how far above the x-axis we had to go, but we also are going to go y units below that. So 2y is going to be the height of the entire rectangle. So obviously that's just going to make a 4xy for the area of the entire rectangle. Now, I think you guys can see here, it doesn't really matter whether we solve this thing for x or for y. So I'll kind of do it the normal way, which is to solve the parameter for y. Just we end up doing it that way more often than not. But this would absolutely work if you went the other direction and solved this for x instead. So y then is going to equal, and this is one big square root now, of 16 minus x squared. So there's the parameter solved for y, and that is now going to get substituted in for that y right there. So area, just as a function of x now, is going to be the 4x that we had there before times the square root of 16 minus x squared. Or, might have been smarter of me to write that as 4x and then a 16 minus x squared in parentheses to the 1/2 power. That is going to make it easier to differentiate a of x on the next line. Now, unfortunately, guys, we are going to need the product rule here, and I think the chain rule within it. So here we go. First factor is just going to be a 4x times the derivative of the second. So that's going to be a 1/2 times the same base, 16 minus x squared, to the negative 1/2 power times the derivative within, which is a negative 2x. So there's the first half of the product rule. Now, plus the second factor, 16 minus x squared to the 1/2 times the derivative of the first, which is just going to be a nice simple 4. So there's our derivative. We want to set that equal to 0 and go about solving this. So, okay, actually that's not bad at all right there. Now, I definitely think it would benefit us, I don't really need that equal sign right there, to simplify this derivative a little bit. So what do I see here, guys? In the first mess, I've got a 1/2 and a 2 that cancel each other out. That's kind of nice. Let's see, that leaves me with a 4x times a negative x, so that sounds like it's a negative 4x squared on the top, all over the square root of 16 minus x squared. And I think that's all I can do there. And then a plus 4, nope, no fraction there at all. So plus a 4 times the square root of 16 minus x squared. Okay. And all of that is going to equal 0. I'm going to take this negative term now and bring it all the way over to the other side to get 4 times the square root of 16 minus x squared will equal now a positive 4x squared over the square root of 16 minus x squared. Now what we're going to do is multiply both sides by the denominator of the fraction. Square root of 16 minus x squared is going to go here and here. All right, and these two on the right are going to cancel each other out. The nice thing is the two square roots we have on the left just end up giving us 16 minus x squared, no more radicals. So the 4 is still there, but now it's times the quantity, 16 minus x squared, and all of that is going to equal 4x squared. Let's distribute that 4 there to get a 64 minus 4x squared equals 4x squared. We'll bring this term over to the right. I think we're in business, guys. 64 is now going to equal 8x squared. We'll divide out the 8 and get an 8 is equal to x squared, and that means that x is going to be the square root of 8, or you could write that as 2 root 2. Perfectly fine if you guys left it as square root of 8. That's not something that I will take off for, nor will the AP graders take off if you guys leave it as root 8 and don't simplify your radicals. So that's what x is. Now, right underneath that, let me just scroll up a little bit right here. We want to also come up with the value of y. And if we remember how to do that, guys, back to where I think I circled it in red right up here. Oop, that's not what I wanted to do. Y is going to be, here we go, the square root of 16 minus x squared. So let me go back to where I was here. And you know what? I probably should have moved this over a little bit. And I guess I'm moving on to step 4 now. Y is the square root of 16 minus x squared. Well, remember, guys, right there, it tells you that x squared is 8. Oh, so y is the square root of 8, just like x was, which is once again 2 root 2. And that means that x and y are actually the same value, and that's going to tell you something, guys. Your rectangle that you had inside that circle, if we want to optimize or maximize its area, that rectangle is actually going to be a square. Now, you want to be careful, guys. I don't actually have the right answer here. They were asking you now for the dimensions of the rectangle, and the dimensions of the rectangle here are 2x for its base and 2y for its height. So I actually need to take these x and y values and double both of them. So the dimensions of that rectangle right there are going to be, it'd be 2 times 2 root 2. So that's 4 root 2 for your base, and that gets then taken by, again, y doubled is going to be 4 root 2 for the height as well. So that would be the actual answer to this question, given the way that they worded it. They asked for the dimensions of the rectangle that would give you the maximum possible area, and those are the dimensions. If they wanted the actual area, you would just multiply these two quantities together here. 4 times 4 would be 16. Root 2 times root 2 is 2, and we'd end up with 32 square units for the maximum possible area of this rectangle. But again, they just wanted the dimensions, so that's our answer there for number 13.